in the next 45 minutes, we'll be proceeding into the industry perspective of, AI fairness and bias. And in respect to that, I would like to introduce to you a very great and important person in the industry, someone who has, given out, someone who has, done a lot in the industry in terms of, AI transparency and bias in credit scoring and his GiniMachine approach. I'll be introducing to you Mark Rudak. He's a machine learning product owner at HES FinTech. He plays a key role in development of the cutting-edge machine learning platform called GiniMachine, a no-code AI solution for data-driven decision-making. I would like to present to you Mark Rudak. Mark Rudak, you have the floor, and thank you very much for being here.
Yes, so thanks for the great introduction. And actually, hello everybody. I'm glad to be here. And so before we dive into the presentation itself, I think it's worth mentioning that there will be two parts today. So first part is the more of a theory. It's a bit of a context, what we are doing, how important things that we develop. And another part is actually the demo itself. And I'll be looking forward for your questions. So let's start. I think I want to mention just a few words about the product, what we do. GiniMachine itself, it's been on the market since 2016. So we are roughly 10 years on the market doing many projects in different countries, different regions. So we actually look from different angles to the business end. And so we gather the information and do many improvements ourselves. And the latest improvement actually we have is on bias, fairness, and so on. So I'm personally very much excited to share with you the approaches, the some insights we do have as of now. So just a bit of context on regulatory, on fairness, bias, that it's getting more and more important as we are getting more deeper into AI. AI is everywhere around us. We do use LLMs, we do use traditional machine learning algorithms. So there are more and more regulations coming up. And for example, in Europe, we do have EU Act and particularly Article 10 and 22 on data governance and automatic decision making. In US, currently, they've been implementing ECOA, and this is on race, sex, and age discrimination. And in LATAM and APAC area, it's just emerging, and mostly they've been focusing on socioeconomic proxies such as age, income, and geographical proxies. So just a bit of, because there will be a practical part after that and a bit of theory. So there are three kind of angles of how we are looking to the features. So there are direct bias identifiers, there are indirect, and according to GDPR Article 9, there are strict exclusion kind of data that is related to health, biometric, and political stuff. Talking about direct identifiers, those are usually gender, age, or race. Indirect proxies, they still must be validated. Those are just few examples of it. Those are zip code, marital status, occupation, and even device metadata. This is still kind of part of bias, but indirect one, because the device metadata can tell us a lot about personal location, for example, right? So, and there are many kind of criterias how we should start looking at the bias, how we should start estimating it. And so worth mentioning that first is data representativeness. is always, and actually is still it's written in AI Act, for example, that for every group, sensitive group that we are about to estimate, I'm talking about the bias, it should be some minimum sample size. So we are not talking about, for example, one sample in the training data. It should be some minimum sample size per group, and then we could start estimating and calculating the metrics. So actually we should use the freshest data when we estimate the bias. For example, we are about to release some scoring model in production, and the bias that shall be estimated should be actually estimated and validated on the freshest data. So our splits, training, test, and validation, those should reflect the reality. So the quality of the data matters. Here we are talking about the labels. So the labels shall be somehow verified. So it should not be random. It should come from the business angle, right? For example, if we are talking about the credit scoring, we should check whether the default or non-default actually happened. So, and the balance of in the samples shall be somehow calculated. So, and there are restrictions on the synthetic augmentation, because maybe some of you know that there are some recommendations on if you want to estimate bias and you don't have enough sample size, for example, uh, you can potentially generate some samples and estimate the bias. We call it post-bias estimation. So it can be done for fairness testing. But if you're about to release this model, if you want to use this in production, don't use the synthetic data. So for bias validation is fine. For model training is actually prohibited. So this slide is on the data, and we've been working with different types of data. And so this table actually shows that the domains that we gather in terms of data, it's auto loans, small medium enterprise, telecom, churn, microloans, and there are those are not examples, those are real features that are presented in this kind of domain-based data sets. For example, for auto loans, we are talking about age, gender, marital status. In SME, it's more kind of proxies for the business description, for example, company age, revenue, region of operation. In terms of telecom, we are talking about whether the person is senior or not, whether it has any dependence. So for microloans, sometimes we see in data the criminal record, for example, signifier or occupation type. So those are still the features that shall be tracked. So this slide is on bias metrics, and so there are basically, I would say there are plenty of metrics, but we mostly been focusing on these two. The first one is called disparate impact, and this is mostly on selection bias. And another one is EOD, is equal opportunity difference, and this is post estimation on true positive rates. And this is actually the performance kind of related metric. So, and there are a few targets that we would like to achieve while estimating bias. So for DI, the target is from 0.8 up until 1.25. And for EOD, the target shall be 0.1. So it should not exceed this value. If some kind of areas are not being met, it should be signifier for us that something is wrong. We need to do something with a bias. And it's worth mentioning, I think, that fairness is not static. So because actually the machine learning itself, and for example, let's say classification type problem, we don't predict the labels directly. we predict the probability of the sample to be related with the target. So, and here, when we estimate the bias, we should take into account that actually while we change in the threshold, the metrics, the bias metrics will change as well. So, and the goal of estimating the bias for different thresholds is to see whether when we move the threshold, model can become more biased or more conservative towards some sensitive group features. We will see it in a practice as well. And this is the description of the case study that I'll be showing in a few minutes. And here, for example, we estimate the bias for the feature senior citizen. So this feature is binary one. It has just two values. We want to understand whether the person is senior or not. And for example, and another angle is gender. And for this particular example, we see that for gender, male versus female, the test we conducted on bias in terms of disparate impact is almost the same for male and female. And EOD is also around 0. So there is no significant difference in true positive rates for different thresholds for male and female. And contrary, if we are talking about the age kind of bias, where we estimated senior versus non-seniors, we see that we got the warning, because for the higher threshold, around, for example, 0.75, we see that our DI dropped to 0.56, meaning that when we move in the threshold, we start approving less and less seniors. So this is actually direct bias towards senior people. And EOD hits 0.23, minus 0.3, meaning that on 0.75 threshold, our TPR dropped 23% for seniors. They actually pay worse. This is a reality of what we observe. So we do have bias, but we also have the grounds, and a business angle can decide what to do with it, right? Maybe we should start approving more seniors, but still there are always two angles. There are always a kind of, so we always think about money from one end and bias from another end. So the few conclusions that threshold is very important in terms of estimating bias. What threshold we choose, it depends. It's actually coming from the business, how risky they want to be. So it could be calibration issue. For example, the model is likely miscalibrated for senior age group. So we need to be aware of as well. So, and overall stats for all features for this particular example is DI pass rate is roughly 90%. Feature violation is 21%. So actually only 1 out of 4 feature got violated. And this is age senior group. And the final fairness score is 75%, which is quite impressive. And we will see the example in a real life demo of it. This is just the takeaways. So a few conclusions that those metrics were automatically detected, no manual work. So we align with all regulators, if you're talking about EU, US, APAC area. So what's more important, that we calculated for different thresholds, so we do have granular visibility. And so we could do immediate actions because we know that there is bias in age, so we can make actions immediately. So now I'm switching the screen to the practical part. So this is actually the model that I previously described in terms of biases. So, and this is the main model screen. We can see here that it's roughly 7K of records were used in order to estimate the bias in order to build a model. So this model is quite predictive with 0.64 Gini index. So we want to also even get more details on the model. Overall, we got 19 columns in our data set with the historical default rate of 26%. So, and for sure, we want to dive into the bias itself. For this, we can download the report and actually, so it got downloaded. Let me change the screen. So this is the screen that shows the fairness analysis on this particular data set. And we see that there is our feature senior citizen. And actually we see that there is violation that we discussed for higher threshold, that is 0.56. And so, and here there are even more takeaways out of it, that there are 4 features that got estimated for the bias. Those are all coming from regulations perspective, from business perspective, and we see that in terms of dependence and whether the person has partner. So we see that if it has for both sides, we see that DI is getting higher, especially for higher threshold, meaning that there is slight bias of when the person has dependent. We actually approve 50% more of these people. So in terms of EOD, we see that there is a higher EOD for higher thresholds. We see that, but still these are not kind of red areas. So it's quite good. In terms of senior citizen, we see that if the person is senior, so for 0.25 threshold and 0.5 threshold, we see that the drop is not so significant. But if when the threshold is getting higher of 0.75, we see that 56% less seniors are getting approved. And this is actually the significant bias in terms of seniors. So, and if we are talking about gender, the bias has not been detected. So our model is fully unbiased towards the male or female. And we see that for small threshold, which is 0.25, the value is fully matching. Here, the drop is slight for 0.5. And for 0.75, we got just 4% more females approved. And in terms of EOD, those are matching. TPR are fully the same for the small threshold. For threshold, somewhere in the middle of 0.5, we got the drop. And for just 2% drop in terms of TPR, which is not significant. As you remember, by the rule that it's called 80% rule in terms of DI and EOD, it should be close. So in terms of EOD, it should be close to 0. And here it's very close to 0, meaning that the bias has not been detected. And here, once again, I want to mention that as of summary, we analyze 8 segments. So every feature got 2 unique values, meaning that overall we got 8 segments, and just 87% of overall amount of segments passed the test significantly. And there are just few violations in terms of DI. Those are not very much significant. And for seniors, the drop was significant, meaning that for higher thresholds, still some bias has been presented. So, and overall, this model is quite good. I would say it, from the business perspective, it shows the practical implementation of what data we have, what biases we observe, how we detect them. And for sure, there are always the question of how we could potentially mitigate the biases. But this is, I would say it's good to discuss in Q&A because this is a wide topic as well. And I guess I'm running out of time. And so I guess this is the end of my presentation. I hope it was very interesting and looking forward for questions. And I'm passing the word to the next speaker. Thank you, everybody.
Yeah, that was really, really insightful. And what I love about this is seeing the full picture. Mark has shown us the technical implementation with specific metrics and dataset control. And Naomi has showed us the governance, transparency, and security framework that makes responsible LLM deployment possible. Mark and Naomi, can you both turn your camera back on so we can go through the questions we have? This is for Naomi. But I don't know. Okay, I think Mark should be able to help us with this as well. So it says, how different is measuring bias in LLM versus traditional credit model? So Mark, you have 45 seconds for us. Do you think you can answer that for us, please?
Yeah, I think
Mark?
I think Naomi can add up something. So I will be mostly on the traditional machine learning end. So as I mentioned, DI, EOD, those are the industry standard. And I can assume for LLM, mostly we should check whether there are any hallucinations in LLM, whether there is any bias. For example, if we are asking some question, so LLM should not respond only based on the gender, for example, or age. So I think, so the short answer is no, the approaches are not the same. They are fully different because traditional machine learning model is based on the tabular-like data, and LLM is based on the kind of let's say, text-like context. So those are just different data perspectives.
Okay.
So this is
Yeah.
my short answer. Maybe Naomi can add up.
Naomi, do you also want to add something on that as well? Because I think we have one question for you as well.
So we can go to the next question. Mark answered very perfectly. Yeah.
Oh, okay, thank you. So the next question for you is, what is the biggest risk of deploying LLM in sensitive financial workflows such as customer advisory, compliance, or risk assessment? And what safeguards are essential to prevent hallucination and biased outputs?
The hallucination is the hallucination and harmful advice is the most important challenge we would have when we train on a biased data set. So the second part of the question was what's a safeguard, are essential.
Yeah.
We need to, consider a diverse data set for training our models, and we need to check if our data is balanced, and we need to regularly check the fairness metrics with like error rates or demographic parity or AI 360 fairness metrics. So these are the, checking the diversity of the data set is very important in training or even fine-tuning large language models.
Oh, excellent insights. Excellent insight from the both of you, and thank you, Mark, and thank you, Naomi.